x on a side by itself. But a few things that that we encountered along the way that might need to rehash a little bit. One thing is something like this. 5x over 2 plus x plus 7 over 8 equals, let's just do 3 plus x over 5. Yeah, this is a linear equation to solve, and we do want to get x on a side by itself, but first here we've got the little matter of fractions, and so we might want to do something about that. Right, and the way we did that, remember, how did we do that? Well, we could clear out the fractions by multiplying by something, right? What was it? LCD. So we clear fractions by multiplying by the LCD, which in this case, we've got 2, we've got 8. Now, that one has a denominator, but it's just 1, isn't it? And then 5. So out of all those, the least common denominator, least common multiple would be 40. Would be the least common denominator amongst those. Like I said, if you have to, just go through, cycle through multiples of 8. 8, 16, 24, until you get one that's a multiple of all the others. So one way of doing it. So yeah, we take that 40 and we multiply it by each part. Even this part gets multiplied by 40, and then 40 times the x over 5. The idea is we're multiplying the same thing by everything, so that maintains the validity of this equation. All right, and what that does is, since that's 40 over 1, we've got a 2 in the denominator, a 40 in the numerator. That can be canceled out, reduced. 2 goes into 40 20 times. 2 reduces by 2 to be 1. So yeah, that just leaves, doesn't it, over here 20 times 5x, which is 100x, over 1, which is just 100x. So we cleared the fraction out is what we're doing. Same thing over here, that's 40 over 1. So I can cancel the 8 into the 40, gives me 5. Now the thing on the 5 is it's times the x plus 7, so what do I have to do there? Distribute the 5. Yeah, so it's 5 times the x and the 7, so that'll be 5x plus 35. No reducing there, just multiplying 40 times 3. And then here the 5, we can cancel that into the 40. That's 8x. Yeah, so now we have our regular run-of-the-mill linear equation. Get the x's on one side. Of course, here we've got like terms, so let's do that first. 105x plus 35 equals 120 plus 8x. Yeah, we need the x's on one side, the constants on the other. So I'm going to subtract my 8x from both sides. Then I'm going to go ahead and do my 35 from both sides. And that'll get me 97x will be what's left on the left, and those go out, so it's 120 minus 35, with 85. And then all you have to do, divide by 97. Okay. And yeah, not all answers will come out nicely. Some will not. So, nice little fraction there. Okay? All right. Now, also, kind of in this same area here, we talked about conditional, contradiction, and identity. All right, what's the story there? What type here did I get out of those three? That's a conditional, isn't it? Conditional one is one like we just worked there, because a conditional one only has a fixed number of answers, right? That's what conditional there's only a fixed number of answers, solutions. Now, in a contradiction, a contradiction is one of those equations that has no solution, right? And then the identity, what about it? It's one that has infinitely many solutions. All real number are solutions. Now, what's the difference amongst those two? Yeah, if I get x equals a number, that's certainly conditional. How do I recognize a contradiction? How do I see if it's an identity? Well, on a contradiction, basically you get a contradiction, don't you? In identity, you get the opposite of that. What do we get here? 8x minus 2 equals 4 plus 8x. Well, on the contradiction identity, on neither one do you get x equals a number. On this one, we just so happen, if I go about solving it, get minus 8x both sides. Well, that's 0, so this side just be minus 2. The right side, the 8x minus 8x is 0, so I wind up with 4. The x terms go out. And so based upon what you're left with, then you've either got a contradiction identity, and of course, if it's a false statement like this, it's a contradiction, right? And then the solution set, if it asks about that, that's the no solution, right? So we're saying this original equation is a contradiction. You can't have that equation. It's a bad equation, in other words. And there is no solution to that. Now, in the identity, one like this, 6x parentheses x plus 4 equals 4x parentheses plus 6 plus 2x. When we work this one out, of course, we got to get our parentheses out there. So that's distributing 6x plus 24 equals distribute there 4x plus 24 plus 2x comes down. We get 6x plus 24 equals, then those two, 6x plus 24. Combine the like terms. And you can see there, however far you need to take it there, but if I try to get my x terms to one side, both sides, the x terms drop out. However, I don't get a contradiction here because 24 equals 24, 0 equals 0, whatever you want to take it down to there. That's not a contradiction, but it's certainly not a conditional because we don't have x equals. That's the identity, isn't it? And the solution set, like we said, is all real numbers. In other words, any number works back in this original equation. X can be any number. 5, negative 5,000. Can be any number. Okay? So there'll probably be a question or two about that come test time. All right? One other thing I was thinking about as I was working that one was this one came up several times, this sort of deal here. Eight x minus 2x minus 9 equals 10x plus 5. Yeah, I wanted to mention this again too, because this little detail comes up a lot, and that is this minus in the front. Yeah, that's going to change signs here, but be sure to change it, distribute it, right? Because this minus affects both of those. So that'll be 8x minus 2x, right? But plus 9, because it's a minus times a minus, so that's a plus. So I wanted to mention that at least once or twice again here as we go along. So then we can combine the 8x minus the 2x is 6x. X is on one side. Now, looks like on this one, I'm going to get the x's over here on the right and move the constant, the 5, over here. So I'm going to subtract 6x and subtract 5. Looks like it's easier. You can do it the other way if you want. But I'm going to get 4 equals 4x, then divide by 4. And I've got x equals 1, another conditional equation. But okay? That the solution set on the conditionals is basically the number that you get. Yeah. The book may list the answers, you know, in a set form, like braces around it, but I don't require that. But the solution set, yeah, is the one. All right. Yeah, the kind of the next thing I'm thinking anyway that we got into was the formulas. There's lots of formulas out there. What we did with them was kind of rearranged them and solve for a different variable. For example, let's say I took a equals let's make it 2 xy plus 3 3xw minus 4z. Okay, whatever. Okay. So if I wanted to adjust that formula there and solve it for a different variable, let's say I solve for y here, just means to get the y by itself. And in this instance here, first of all, well, I've got the y term here, so I need the other terms to go away from that side, so I need to get rid of these two terms, which would mean subtracting them, 3xw, and then adding the 4z, wouldn't it? That'll get rid of those terms. Now on this side, I can't combine those, they're not like terms, so I'd have to just leave those basically as is, but this side, those go out, so that's 2xy, and then just divide off the 2x to get y by itself. Right, because that'll cancel those out. Now this one also brings up the point here. Do these x's, can I just cancel those out? No, I can't cancel those x's out. That's kind of what we did in the other chapter there. yeah, this 2x divides all these, so before I can cancel it, I would have to separate it, and you can do that if you want to, but I'm just going to leave it right there like that. The other thing we talked about in the formula, a little bit different, and maybe something else we encountered, was the one where I remember the exact formula here. I probably should, but something like that. Okay. Yeah, if I solve that for f, one way I could go there is, add the 32, but what I could do then to get f by itself, since that fraction there, one way to get rid of course, would be just divide it by 5/9, but the way to make it look a little bit nicer is to do the reciprocal, multiply by the reciprocal. So that's what I'm going to do here. I'm going to take my right side there and multiply by the reciprocal of 5/9. So I have to do that on this side too, because that'll cancel the 5s and the 9s out. And that does bring up the point, there are alternate answers there too. So you could get something slight bit different looking, but still be okay on that. Depends on which way you go. All right. Questions or concerns on anything right there that I have? Okay. All right. Well, move along then to some other stuff here.